A very good afternoon to everyone. On behalf of the organizing committee, I am welcoming to all the dignitaries, our eminent speaker for the day and participants on this fourth day of faculty development program on future trends in machine learning and data science driven IoT applications, FTMLDSA IoT 2025, organized by the Department of CSEDS in association with the Internal Quality Assurance Cell IQAC of Haldia Institute of Technology, an autonomous NIRF ranked institute under IQAC Haldia, in collaboration with the Department of CSE Budge Institute of Technology and the Department of CSE Dr. Sudhir Chandra Institute of Technology and Sports Complex. Participants are requested to follow the session attentively on the respective platforms as usual. You can put up your questions for our eminent speaker via the designated chat box. The attendance form will be shared in the chat box during the session. It will remain open for approximately 1 hour, so please ensure your response within the given time frame. We are honored to have Dr. Indrajit Banerjee with us today. Dr. Banerjee did his PhD from the Bengal Engineering and Science University, Shibpur, on the year 2024. He received the Chester Shaw Award from IEEE Transactions on Consumer Electronics, the USA in 2016 and 2022, and received several Best Paper awards. He is reaching the IoT, WSN, cloud computing, security, etc. Under his guidance, several students have already completed their PhD work. He has conducted numerous research projects sponsored by MOIL India, DST India, West Bengal, DHE, STB, AICTE, UGC, etc. He reviews various international journals such as IEEE Transactions on vehicular technology, IEEE Internet of Things Journal, Computer Communication, SBR, ad hoc network journals, etc. etc. He has patents on different IoT devices and has several software copyrights on related software. Without further delay, I am delighted to invite Dr. Indrajit Banerjee sir to deliver his talk on this topic, Advancements in IoT Security and AI-driven IoT application from automated anomaly detection to future trends. Welcome, sir. Over to you.
Okay. Am I audible?
Yes, sir.
Thank you. First of all, I would like to thank the Institute of Technology for giving me this opportunity to share my ideas and research in my topic, in my fields. However, my area mostly on IoT. I started my journey obviously from very old wireless sensor network. I did my PhD on that particular field, and later on, now I am shifted to this area. So let me first share my screen and start talking with you guys. Uh, okay, so today my topic of discussion is advancement in IoT security and AI-driven IoT applications. Basically, I'm giving a focus on anomaly detections, right, and its future trends. So basically, in this particular discussion today with you guys, that my objective is to share uh, the area in IoT and the new trend, the AI, artificial intelligence, where we can focus, where you can do a further research on this field, right? So that is my area. First, let us give you an idea that in AI, ML, where you can do a lot of research, next gen research, and then I would like to show one of my students, BTech students' research in this particular field. Uh, so before we start, let us discuss about IoT. So if I see the brief history of IoT, IoT, the concept was first came in officially it was known in 2013, right? Earlier to that, the question is there any concept of IoT, Internet of Things? Yes, it is, obviously. To understand that, before the name which was proposed in 2013, we come back to the 2074 when the TCP/IP protocol was first initiated by the researcher. In 74, there is no concept of wide area network that we currently have. But this is the beginning of wide area network. At that point, there are main objective is to connect the computers between the different universities and the research groups. Then the concept of internet came into the market. So TCP/IP was there before the internet is there. Nowadays we are doing the socket programming and everything on the basis of TCP/IP, and that is very old network. So that's why, though there is a controversy, we know that IP is now well accepted all over the globe. But I can say that IP is not the best protocol whatever we have in the layer 3. Right? In network layer 3, IP is not, according to my concept, my own opinion, IP is not the best protocol available. But still, we are using IP because no other options are available. Though there are other protocols like ATM and all are available, but they are not get popularized because of so many reasons that we may discuss in some other days. However, IP is the, as of now, the combination of TCP or UDP with IP is the protocol. Now, in the 1990, people have done some research that a device can itself get connected, other than computing device, a device which is not doing the computation, but it is doing something else. That can also be get connected to the internet and also feeding some data of its own, whatever it is connecting. That concept was first came into the concept in the year of 1990. At that time, IoT is not the name, right? But a device which is not doing a computation like what computer will do, but obviously there behind there is some computation, but what we understand by the computation is that processing of used data, doing writing a letter and all that kinds of application software. They are not running an application software, I can say, but a device which is doing some basic computation of the data that is collected and feeding into the internet to or some other place it can transfer. That concept first came in 1990. Then obviously after that in 1991 the web page we have seen HTTP with the protocol, and then in 1999 IoT is coined for the first time. Even that in 1999 it is not IoT, right? It is a kind of device which can collect the information from its environment and feed it via internet to another device, right? Then after 2013, we came to know about the Internet of Things. So Internet of Things is what? It is a tiny device which is having a processor, maybe a microcontroller of small size, which is again we can do some kind of coding on it. We can ask the controller to do according to my requirement, and it is associated with some sensors. Those sensors are basically collecting the environmental information, like depending on the application area. If it is industry, then it will collect the information from the industry. If it is health, then it will collect the information from the health area. If it is used in any other field like car, any other area, weather monitoring, for that purpose, those sensors are basically responsible for collecting the information from the environment and then feed into the via internet. It feeds that data to a central repository where we will finally process that data and do that. So in everywhere, the internet is very vital for communication between the node. The node means the device with a sensor which is collecting the data, and to the central server, you can say, that may be in the cloud, that may be in your office, that may be in your institute, which is basically processing the data at the end, right? But once there is a internet, there is a connection between the two devices via wire or wireless communication, there must be someone else would like to try to interfere into your work. So in 2016, why I am giving this 2016, because 2016 various internet attack. One of this kind is that MyDai botnet attack. So MyDai is basically a kind of probably it is a French or Japanese word used for it's a botnet. Botnet is basically kind of malware. Basically, MyDai attack is basically on Linux-based system. Say, for example, you are having that camera in your home, which is basically used for CCTV purpose. I would like to monitor, take control of your camera at your home from the outside. That is the MyDai botnet attack is doing. So it is basically a distributed denial of service attack, which is basically creating a huge, immense that what I can say that the people. Achha, Neha D has raised his hand. Yes, Neha, do you have a question? Would you like to ask something, Neha? Okay, probably it is by mistake you have done something. So this botnet, why I'm taking this name, because from 2016 onwards we came to know that there are something which is also disturbing our IoT devices. Someone else from outside may take control of my device and do some nasty work, right? So obviously, and into 2020, IoT device is exceeding 20 billions, more than 20 billions devices are nowadays there available in market, connected device. Now let's go back to the topic, the evolution of IoT and the data sciences, the role of data science in IoT. IoT is Internet of Things, is basically a device which I already told you with the sensors. These sensors are basically responsible for collecting the data from the environment. Now, since it's automatically collecting the data, that data definitely is of huge volume, because every time if I collect per second, if I collect one information, say for example, if it is a temperature information of my room, then also at the day end, it is think about how much seconds we elapsed and how much data that we have in a single day. Now think about into 365 how much data that I have for my temperature in my room data. That is only the temperature data. Along with that, how my AC is performing. For that, if I attach the humidity, if I attach the rotor speed, if I attach the sensors for ampere current, such that my objective is to know how my AC in my room is performing, right? That is the basic objective. So uske saath I can add a lot of sensors like temperature, pressure, not pressure, obviously that line pressure, that fluid pressure I can also measure. That gas pressure, we can always know that the AC is running on a compressor, which is basically using some kind of fluid is behind this, which is basically taking out my using a Carnot law. It is taking out the heat of my room and getting out in the outside, right? By following the Carnot law rule. For that, we are using some refrigerant into it. Refrigerant has having a pressure, so pressure sensor maybe I can attach. I can temperature, humidity, rotor speed, the ampere, voltage, these kinds of things. Now, that huge of data that is there in my central repository, that is spreading in from the one simple IoT device in my room, I need to monitor my AC. I need opportunity to take some intelligent decisions, right? So the machine learning algorithm, the data science algorithm, the data science is obviously a part of AI. Machine learning is also a part of AI, and IoT is a device which is basically collecting that information. So these three together, hand by hand, they can do enormous things for us, right? So they are very much interconnected and they are very much useful for our applications, right? These three domains work together to extract a valuable insight from the IoT generated data and drive smarter applications, right? Now let's move on to the further key machine learning trends in IoT. So before I go into my walk, let me give you an idea that the machine learning as an algorithm is nowadays everywhere there are AI and machine learning. Now I'm just want to highlight you some key machine learning trends in IoT where we are doing research. The first idea I'd like to discuss about the edge AI and federated learning. What is edge AI? Nowadays, IoT means a node which is acting as an edge device. What is the meaning of edge? Edge means in a cloud computing environment, you can say, where is my server? I cannot view it because it is in the cloud. Cloud means what? It is nothing but the internet. The server is not installed in your room. Now the server is in the cloud, in the internet, somewhere else. So that is why we call it a cloud computing. So that's, though the server is not visible to me, but the end device, that is my AC, my washing machine, my microwave, those which are connected to the internet through the cloud central server, which is feeding my data to my mobile phone. From my mobile phone nowadays, we can easily control my home AC. I can control my home washing machine, right? So those AC, washing machines, or any kind of IoT device are considered to be as a edge devices, right? Now the question is that how you are try to protect that edge devices, right? Here the federated learning is a mechanism, right? So this is basically a rapid growing mechanism trends in IoT cloud where we are basically able to control the federated learning mechanism. Is a mechanism where what we will do, instead of doing the processing in say for example authentication, I would like to do some kinds of authentication into my device. Now federated learning based authentication mechanism means instead of taking the device's data entirely, I can allow the devices, the edge devices I'm talking about, they can do their job of their own at their own system, and collectively they are feeding my data in the central server, and in the central server by collaborating those inputs from the different edge devices, I will take a decision. So this is a kind of distributed authentication mechanism if it's a federated learning based mechanism. So federated learning with edge AI is nowadays is a new trend of this particular area of research, right? Now let's move on to the next topic, self-supervised learning in IoT. We know that supervised, any machine learning algorithm can be categorized into two categories, that is a self-supervised learning and unsupervised learning. What do you mean by the supervised learning? We know all that supervised learning means if my data all are labeled, all the data fields are known to me. As if it is data of temperature, that is labeled with the temperature information. If the data is from say humidity, it is labeled with the humidity information. That is, all the data belongs to which category that are all labeled to me. Then we know that what types of data it is. Then we can feed into a supervised learning. But it is not always possible and give us a huge constraint that if we want to manually label all the data sets. Now where the self-supervised learning can help us a lot nowadays. So it's reduce the labeling cost. No need to do the large manual labeling data set. Handle unstructured data. So work on IoT data. Mostly IoT are feeding you the data from the sensors, right? That may be an image, that may be an audio, that may be a logos or anything else, right? So that kinds of unorganized data can easily be handled. Unstructured data can easily be handled by a self-supervised learning mechanism. And it also helps you to continuous learning of that data and also improve the data efficiency. So self-supervised learning is a new generation of research what we are doing for supervised machine learning algorithm. Now, next topic of discussion is explainable AI. This is also a hot topic of in AI era. What is explainable AI? We know that AI is basically taking a decision on the basis of the data that we are feed into it. Right? First, what we need to do? We have to first train our data. So whatever data set that we have divided into two parts. One part is used for the training purpose, and another part is doing the testing. So after my model is get ready with the training data, I can test with my data, and then I am say that my data is ready, and I am putting it for a decisions. So any new data will come to me, I'll take a decision on the basis of my already pre-trained data. That what is the pre-trained model will do, right? So pre-trained model, like you can say the ChatGPT is a pre-trained model. So it is taking a decision on the basis of pre-trained information, right? So GPT, P is a pre-trained, right? Now the question is, from which section of the data is basically manipulating my decision? That is need to be known by us. Can you get my point? I have a huge data set. On the data set, which, say for example, I am taking a decision that my AC is not working perfectly at this point of time. Now I have a temperature data, I have a humidity data, I have a current information data, I have a voltage information data, I have a rotor speed data, I have a pressure information data. Now out of those data sets, which data is basically giving me the decision or influencing my decision engine to take that decision that it is malfunctioning or it is perfectly working? That is not known to us earlier to that. Now explainable AI will give us that facility to understand on the basis of which data set we are taking that decision, right? So for example, in the healthcare, in the smart cities, industrial automation, we are applying two models, basically the shape models and the line models, right? Shapely additive explanation and line is a local interpretable model, that analogistic explanation. So this is a basically a decision tree and a rule-based model which are helping us to understand my AI model will take a decision on the basis of on what types of data and what types of data are responsible for taking that decision. So that is nowadays another interesting research is the explainable AI, or in short XAI, right? Now, next is reinforcement learning for IoT optimization. Reinforcement learning is another domain of machine learning algorithm. It is doing what? Other than supervised and unsupervised learning model, reinforcement learning model basically train the data set on the basis of rewards and penalties. Right? So what we will do for our young generation, young chaps, say for example, as students in your class, if you are a faculty, you know that you are giving some rewards to our students if he is doing the right thing in the class. And if you are you are also punishing our students by in the means of obviously the marks and awarding him some applause, right? So you are applauding our students, giving a higher marks if the students is doing the right thing, and you are also giving him a small low marks if the students is not performing well. So you are basically doing the reinforcement learning to your students. You are encouraging our students to learn perfect things, and you are discouraging our students to learn the wrong things. So it's the same way the reinforcement learning algorithm is also doing the training a particular model, taking a decision on the basis of that. Right? So this is also a hot topic in IoT optimization case. Now, advanced data science for IoT, this is the next topic I'd like to discuss, where data science already has, I told you that this is a major area in IoT research, because IoT is generating huge amount of data, and data science will help us to analyze the data. Now, what are the advanced data science models of there? The first topic is automated machine learning algorithm. What is the automated machine learning algorithm? As of date, we know about the machine learning algorithm, but AutoML is what? Automated machine learning algorithm, basically what we are doing, we have a hell lot of machine learning algorithms are there. So IoT devices are giving us our data. Then using that data, we are processing that data with manually. So if there are any null value, if there are any vacant space are there, we have to field it. Then we have to process the data. Then we have to select a particular ML algorithm which will fit good for our algorithm. And then we are applying our data set, train that data. Using the data set, we are training our proposed model, and then what we are getting the results. Now, this every steps, data processing, data model selections, and all we are doing manually. Is that possible to do everything automatically? So if that is possible, that is what automated machine learning algorithm. So machine learning, we are try to design a model which can do all this selection, data pricing and everything of their own, depending on the type of data, what it is getting. So that is what is auto ML. So this is another area of research which are currently going on in data science. Next is time series forecasting and anomaly detections. Time series forecasting is also an important area which basically predict a narrative technique which used for historical data and forecast the futures. I don't know whether it's the portion is visible to you or not. Sorry. Now, time series analysis and forecasting is basically uh, it's a predictive decision making algorithm. So what is basically predictive decision making algorithm? Say for example, I have a data set. Using the data set, we are training our data and taking a decision. Now I don't know what is going to be happened in future. Now can my data set give me a future data which may be come in the future? If that future data set is also available, but if I know that the data not in 2025, the data which are coming in 2026 and 2027, if that kinds of market analysis data is available with me and if I can train my model accordingly, then in future my model can easily take a decision on the basis of my future data that what will be the, say for example, if it is a stock market application, what will be the best stock I would like to invest since I have a future data in for 2026 or 2027 market, right? So what Trump will do if I know early, then definitely I have an advantageous position for my market investment. So that is what is the time series forecasting and anomaly detection algorithm will do. So this is a predictive decision making algorithm. This is also help us in IoT application. This is also another neural research algorithm. Now, graph neural network is also a very interesting area for IoT. Since IoT is a small tiny nodes which are connected between themselves and collecting the data from the environment collectively. So neural network or rather graph neural network can help us a lot because graph neural network can is a graph-like structure, data structure, which help me to connect those all the, say for example, 1,000 IoT nodes in a graph-like structure. It will help me a lot to analyze those data. So it is also a deep learning model which is helping us to analyze the data and taking a proper decision, right, on the basis of the relations of the data sets. So this graph neural network based IoT applications research is also a very important area of research nowadays. Now, synthetic data generation and digital twinning. Synthetic data generation means we are collecting the data from the nature, from the environment. That's right, perfect. But can we not generate the data of our own? Sometime we'll do that. That is what we call the synthetic data generation. We are not collecting the data originally from the by applying the IoT nodes. Rather, we are generating the data of our own in a lab environment synthetically. So this also gives in our sometime in our research for training and testing purpose of our proposed model, we also use this. So synthetic data generation and digital twinning is also an important area of research in data science and IoT field. Now let's move on to the security and privacy in IoT with ML and data science. Once there is internet, there is obviously a problem of security, right? So first topic of discussion is AI-driven intrusion detection system. Intrusion detection system is basically available IDS system, which are available in the market. The IDS is basically doing what? It is analyzing the internet traffic and taking a decision on a different layer of communications. It's maybe, sorry. Okay. So IDS, someone else has Rashid. Rashid, could you please switch off your thank you. Now, Intrusion detection system is a system which is available, very age-old system, which is basically analyzing internet traffic in a different layer of internet communications. Layer means ISO is a layers. I can analyze the traffic in data link layer. So on the basis of the frames that we are receiving in data link layer, we are taking a decision whether the data is the frames we are receiving are there intruding into my system or not. In the layer 3, in the IP layer also we can take a decision on the basis of our IP address, that whether it is intrusion or not into my system. So in a different layer we are taking a decision. Now that decision, can I take help using the AI driven model? So what does help that we are getting if I apply the AI and the machine learning and the deep learning algorithm into it, that helps me to prevent my this kinds of intrusion detection system in advance way. So that can do in an automated way, in an advanced way to do that. So AI is also, along with the intrusion detection system, is a nowadays a huge research going on that particular area. The next area of research is a blockchain and secure IoT transformation. Blockchain, we know what is doing that. Blockchain is a mechanism where if instead, say for example, in a classroom, you are distributing a question paper among the students. Now, when you are distributing your question paper in the student in the classroom, is there anyone in between? So you are handing over the data to one person, and that data is handing over to another person, that data is handing over to another person. In that way, the question paper is moving on. Is there any chance that any of the intermediate students can tamper that data? Obviously, they can do that. But if I apply the blockchain mechanism during the transformation of my data, if I allow our students to sign on it, right, and then forward it to the next students. So when the final student will get that data, he will get the signature of all intermediate data. So in blockchain mechanism, we are also doing something like that by doing some cryptographic mechanism. So every one intermediate persons will do the hashing and put some data into it, so that if somebody in between will tamper any of the data, the final person can easily identify their data, whatever he has received is a tampered data. Nobody in a consensus, we are taking a decision. So among the 50% of the entire data set, if they are unable to secure that particular thing, it is not able to, nobody else can able to do any kinds of tampering into it. So that's, I'm not going to discuss any details of blockchain algorithm over here, that you can easily understand from your internet search. But blockchain is obviously nowadays a mechanism which is a very much important area of research in IoT transactions. Right now, differential privacy and homomorphic encryption. These two are also very important in nowadays of research. Now, I have a slide for this two especially because these two are very important to me. Differential privacy, by definition, we can say it's a mathematical framework, basically, which ensure that statistical queries of data sets do not reveal the individual information. What does it mean? It means, say for example, I have a data from all my students. Now, those students' informations are supposed to be stored into my data sets. And now, on the basis of that students' information, we are taking a decisions that whether we should take this kinds of device or that kinds of device, whether we should allow this kinds of company to come or that kind of company to come. Now, those student information is very vital and they are very much private for that particular students. I cannot disclose them. So differential privacy algorithm will allow me to prevent the individual students' information, and when we are transforming it to the central server for processing or taking a decision on the basis of that, we are doing randomly putting some noise into the data, so that that central server may do some processing using that data, but they cannot unable to understand what the actual data is, right? So that is what the differential privacy algorithm is. So it's a smart city. So it's one example is that, you know, collect the traffic information, GPS enabled information of all the vehicles. Now I don't want to disclose, sorry, I don't want to disclose the GPS information of the system, but I want to analyze the traffic. For that purpose, differential privacy is an important area. Homomorphic encryption is another type of, which is basically cryptographic methods that allow the computers, that allow the computation and encryption data without decrypting it. That means what? Again, the same idea, differential privacy kind of idea. In the differential privacy, we are sending the data to you with a noise. In a homomorphic encryption mechanism, we are sending you data with a encryption mechanism, and you are not allowed to decrypt it, but you are taking a decision on the basis of that encrypted data only. See the beauty of this homomorphic encryption mechanism. It encrypts the data, but giving us some private by protecting my privacy, but you are have a capacity or capability to take a decision on the basis of that encrypted data. So encryption was done in such a way that you cannot disclose, my data is not disclosed to you, but you are taking a decision on that. So for example, in a hospital environment where the patient's records are very much private to the patient's parties, but we have to take a collective decision by the researchers, by the doctors. So the doctors, without getting in the private information of patients, they can take a decision collectively. So this is the homomorphic encryption. So these two are very promising area of research nowadays. That's why I mentioned this too. Now, next is the real world applications of this particular area. So we are discussing about IoT applications using machine learning and data science. So IoT application is with the machine learning and data science. The main area is the smart city, predictive maintenance. So in smart city environment, like our new town is a smart city, we declared it as a. So in new town, different, say for example, we are planning to, but actually we are not able to implement it in such a way. But our plan is to implement that all the meters should be smart, all the water supply meters should be smart, all your traffic lamps should be smart, right? In that way we are planning to, but not yet implemented in such a way. But in smart city, this is the idea that where we can do the everything will be whatever the device that we are giving the facility services to the dwellers are of smart kind. So we have to apply the machine learning algorithm and AI algorithm into there for taking a better decision on. Healthcare IoT and wearable device, this is another area where we can apply this idea. Industry, obviously, Industry 4.0 standard says that we have to design a state-of-the-art industry where entire industry will be monitored using the IoT devices. They can be monitored from a central server room, and the industry will run automatically of their own. So there, obviously, since the IoT device have to be installed, they are feed us a huge amount of data. So we have to monitor them using this our smart AI ML algorithms. Autonomous vehicles and intelligent transportation systems is another area of this particular IoT applications. In nowadays, we know that all the cars are smart cars, right? Smart cars means your car are equipped with the multiple sensors. Those sensors are collecting not only your GPS information, but also your proximity information of the other cars. And accordingly, those cars are sending data to the central server, and the server will take a decision. Now, few companies like BYD and Tesla are implementing this autonomous vehicle system in their cars. In India, the Mahindra, you probably have known that Mahindra has launched a new B6 car, that full electric car. In that car, also have a portion of this kinds of autonomous vehicle system information is there, right? So nowadays, the Indian companies like Tata and Mahindra is also coming out this kinds of autonomous vehicle systems. Though partially, not fully, but still they are working of their own, right? Like XUV 700 again from Mahindra, having this partial facility that can also have a option to drive. Self-drive option is there, but not as good as Tesla, but partially it is working well in Indian road conditions. And B6 of Mahindra is also there, which is also giving us that facility. So this is the area of where industry are also working. a lot in India, obviously. Now let's come to as of now we are discussing what we can do in the research. Uh, Now let's come what we have done. This is the work done by one of my BTech students group. They have generated using a IoT device, and they are basically detecting the anomaly in a industrial IoT. That is the main target. But this is they have generated a lab-based system. So what they have done, this is the uh, this diagram shows basically what cloud architecture will work. Here in cloud architecture, normally this is the cloud, this is the central servers which are basically storing the informations. Then there is the internet. Those servers are connected via internet to the edge devices. Edge devices means the IoT devices which are collecting the data in a real-time system, right? So this real-time informations, whatever the edge devices are connected, they are sending it through the edge gateway. Edge gateway means it's maybe a API, AP access points, or maybe you can consider as a router in your system, which are sending the information and then finally goes to the your cloud. Your cloud means your server, which is again connected through the internet to your edge devices. So the objective of iDetect system is to focus on developing an autonomous detection or anomaly detection system, anomaly detection system that monitor the temperature sensor data of industrial environment. Here we are only focusing the temperature because we are only calculating using one of the sensor of its kind. Though we have proposed a various other sensors like humidity and all, gas sensor, humidity sensor, these sensors also we are considering. But as of now, we this particular application only had done using the temperature sensors only. And what the anomaly are there in the temperature sensor that we are going to detect. Say, for example, if our sensor is performing well, or the device from where we are connecting the data, that device is performing well or not, is there any sudden spike or drop in the temperature that we'd like to monitor using this algorithm, proposed algorithm. So this key contribution of my students is the machine learning model that they have proposed, and they have proposed that isolation forest, LSTM, and one class SPM. They have proposed this three model to monitor this particular device. Okay, there are some chats are going on. Some questions are there in my chats. I don't know how to check that chat. It,
Sir,
huh. Is
first
there any
question.
question?
First question is, how do IoT devices balance the need for real-time processing with the limited computational resources available on device?
Okay, okay. Very nice question. Uh, IoT device. Acha, let me. Can I take the question at the end, so that
Okay, okay,
let
okay,
me
sir. Okay.
finish it, and at the end I'll answer. But however, this question is very important to discuss. That IoT devices are having a very small computation. Uh,
And another
okay,
question, can you please compare FHE with blockchain?
okay, okay. So let me finish my presentation, then I'll
Yes,
come
sir.
to
Yes,
this.
sir. Okay.
So this three model my students have considered: isolation, forest, LSTM, and one plus SPM. Why they have considered it? Because they have gone through a literature survey. In the real world literature survey, they have find that Das et al. Is working on a similar kind of area where they have used the MQTT as a protocol. Sorry, MQTT as a protocol they have used. One of the Fang et al. Has used the graph neural network, and Zhang et al. Has used the one class SVM, and this Mustaq et al. Has used the long term SVM, LSTM model, right? Long and short term memory model. So that's inspired my students to use all these models together to check how their model is performing with that. So what they have done, they have taken a few nodes. These nodes, whatever we use, they have used the node MCU ESP8266. This is the node MCU, and along with that, they have connected one temperature sensor, DHT11 temperature sensor, and then they have used the MQTT broker service, MQTT network they have established. Through that, this is you can consider as an edge device, and this MQTT broker you can consider it as an intermediate fog layer. You can say it, and this MQTT whatever publisher is publishing using this MQTT broker that will goes to the subscriber. Subscriber means a mobile device here, which is basically collecting all that information for their display. Okay. Now, this information, how it is working, the proposed model, let me share with this. So here is the sensors, which sensors are collecting the information. They may be gas temperature, air quality, and everything. Here in our case, we are considering, for this particular presentation, we are considering only the temperature sensor we are sending to the broker. Now, after the MQTT broker is getting that information, what it will do, it will process that data, right? So that data is stored in a device, and then that device will process that data. So we are uploading that data using the AWS EC2, right? So AWS EC2 is a platform which help you to collect the data in a cloud. So this cloud we have purchased from the AWS, that means Amazon Cloud Services, and there we are keeping the data, and also not only keeping, we are also pre-processing that data. This data we are feeding into the three different models. First model is one class SPM, second model is isolation forest, and third model is LSTM classifier. Then we, after the prediction engine will predict, and then finally we are try to find out the anomaly. That anomaly data we are feeding to the subscriber. The subscriber can see the temperature analyzed data. That is the main diagram, flow diagram of the proposed model. So one class SPM, this is a basic discussion of about the one class SPM. What is in one class SPM? It is a classifier anomalies by separating the normal forms of abnormal data in high dimension. So this approach having some advantage, having some disadvantages, and on the basis of that data, we got this is the performance of our model. So we have calculated the precision, recalls, F1 score, and accuracy. So 87% accuracy it is showing by the SPM 1 class SPM. Now this is the pictorial depiction of the data. Let's move on to the next. That is isolation forest. Isolation forest is also another concept of machine learning algorithm, which is basically anomalies detects on the isolation outlier from the majority of the data using randomly generated decision tree. So this also have some advantage and some efficiency, and finally it shows us the precision as 0.46 and recall as 1 and F1 score and the accuracy. Obviously, this isolation forest gives us the maximum accuracy of this. And low LSTM is also, this is the LSTM model, pictorial depiction, and LSTM types recurrent neural network, RNN model, and designed for handle the sequential data sets, and particularly useful for time series anomaly detection. This is the basic definition of random LSTM model, and it gives us a performance something like this. So if I compare the entire performance of all the model, we'll see that isolation forest will give us the better results compared to any other model, which is giving us a 75% accuracy. Right? So this is the accuracy table. The algorithm 1 class, LSTM, and isolation forest is giving us a maximum consideration. So our BTech students has finally concluded that in their case, in their scenario, maybe in some other cases, some other model may perform well. So they are showing that their isolation forest in this scenario, they also implemented some other random forest, FSSEL card, random forest, and LSTM model also parallelly, and this shows that the other proposed model proposed by some other authors have given this kinds of accuracy with their data sets, but isolation forest is giving them the maximum benefit of this, right? So this is what they are predicting. So this is a simple BTech project as done by our BTech students, and they also published this as a paper. Now let's come to your question. First question you have asked as of now is that whether this tiny devices, how they can mitigate that data, right? Huge amount of data. So IoT is obviously, IoT is a mm, device which is basically as I have shown in my students application here also, they have used a small MQTT Node.js model, right? So they are collecting. This is used for collecting the data. So this device controller is unable to process a huge amount of data. So what we did, we send that data, publish that data, and send it to the MQTT broker. Now this broker here in the MQTT broker is basically doing the processing. So you can say this is the edge device, this is the fog device, and this is the and you can see the subscriber, or you can consider it as a cloud or fog device. So instead of processing the data entirely in the edge because of unavailability or because of the low processing power of the edge devices, we are have to rely on the fog or the cloud device for our basic processing of our information. Is that okay? Am I able to give you an answer?
No answer from
Any
that.
any other question? Okay. Yes, probably. Yes. Okay. Thank you.
Can you please compare FHE with blockchain?
Where is the paste it here? Where is my presentation notes? Where is blockchain? Word. Sorry. Where is the correct question? Let me come to the question. What is the question? If sorry, can you repeat the question?
Yes, sir. Can you please compare FHE with blockchain?
FHE.
Fully harmonic encryption.
Okay. Fully harmonic encryption is obviously is a type of encryption that allows for computation and performance directly on the basis of encrypted data without need of any decryption, right? So blockchain may not be the right comparison with FHE. Rather, this homomorphic encryption is a you can mostly compare with FHE, right? Blockchain is a something different, and you can compare the homomorphic encryption mechanism is kinds of FHE, fully homomorphic encryption.
Okay, sir. Another question from the
Or
participant.
rather, the question is that homomorphic encryption is blockchain encryption or not? Now, blockchain is something different, and homomorphic encryption is something different, right? Blockchain is used in my example. What I am giving that, say for example, there are 10 people are there in a group. Now, out of this 10 peoples, if 70% of them are agreeing on a basis, on a point, then only we are taking that decision. If 30% are disagreeing, then
No, no, sir. No problem.
huh. So that is what the blockchain is. Blockchain is a collective decision of the. This is the one example I'm just giving. However, in details, I'm not discussing here about the blockchain. But homomorphic is not a blockchain. Okay. Next. What else?
Uh, Another question from participant side. Can you share the tutorial hands-on demo of a basic project where some of the concepts discussed herein have been implemented?
Basic projects. This so again, you would like to. This slides I can share with me whatever I have. But other than this, what example, what slides that you want?
I don't know, sir. I think they want some demo of a project.
Demo of a project. Okay, demo
Yeah.
of a project means normally what happens. You see that what my students in ISC Shipur are doing, that not all, but few of them, they are those who are interested with. They are developing using that. Here I am. giving you the idea. Here the students have taken some Node.js, Node MCU, and then using some sensors, different types of sensors, they are connecting with that. Very recently, just before this particular presentation, one group of students came to me, and they are looking for they would like to implement similar types of projects. They are using that instead of Node.js, they are using what Arduino Uno. Arduino Uno they are using, and they are also purchasing some temperature sensor, humidity sensor, and some kinds of sensors from the market. And the beauty of that, these sensors are very low cost. You can also easily purchase those sensors from the market. And if you have the Arduino Uno, Node.js, or anything, you will see from their website you can easily have a hell lot of support on that particular node. Right? You can do the coding from the supports of the websites itself. And it's very simple and very easy C++ coding. So using that, and then connect those devices using simple connector that is also available in the market, and example codes are also available in the market, right? So just make a search in the website, you will easily get that things, and you can get help from there, right? And
Uh,
obviously this guides whatever I have, I definitely share with all of you. Yes, practice.
okay, from Pravesh Kumar, he wants to know the security concern with blockchain.
Sorry.
He wants to
Can you
know
repeat?
security concern with blockchain.
Security concern with blockchain.
Yes.
So, security concern with blockchain. Blockchain is basically a decentralized, distributed algorithm, right? That is basically used for the purpose of security itself, right? So, I don't get you the question actually. So blockchain is basically itself is a security algorithm, and it is based on cryptography. And as I already told you, this is a consensus mechanism. That means instead of taking a decision by a single one, if multiple nodes or multiple people are on consensus, they are taking a decision. So it's a kind of cryptographic algorithm used for security purposes. You know that in modern days, that Bitcoin is using this particular blockchain algorithm for transformation of data. So it's a one of it's secured mechanism for transforming information, right?
Okay, sir. There are no questions from participant side.
Okay.
Uh,
Thank
uh,
you. Thank you.
Thank you so much for delivering such an informative session. I'm sure all the participants found it highly insightful and useful. You have explained nicely on IoT security and AI-driven applications. Your explanations on automated anomaly detection and future trends were incredibly engaging and thought-provoking. Thank you, sir. Thank you for sharing your expertise. So, sir, before leaving, uh, I want to share some. I want to share the token of appreciation with you. Thank you, sir.
Okay.
Uh,
Thank you. Thank you again to Haldia Institute of Technology for giving me this opportunity. Okay, so may I leave?
uh, yes, sir. You can.
Okay, thank you. Thank you all. Thank you all participants.
Sharing টা মানে হয়নি প্রথমে। On that note, we are concluding the session for the fourth day of the FDP. We request all participants to join tomorrow's session, not tomorrow, to join on Monday's session at 3 p.m. The meeting link will be shared in the WhatsApp group prior to the commencement of the session. Thank you. Thank you all.